Hello, my name is John Moyer, and I want to welcome you to the NIH Office of Disease Prevention's Methods Mind the Gap webinar series. This series explores research design, measurement, intervention, data analysis, and other methods of interest to prevention science. Our goal is to engage the prevention research community in thought-provoking discussions, to promote the use of the best available methods, and to support the development of better methods. Before we begin, I have some housekeeping items. You can submit questions during the webinar via the chat pod. You'll need to open the pod by hovering your cursor at the bottom of the Zoom window and then clicking on the chat icon. Please direct your questions to hosts and panelists. We will open the floor to questions that have been submitted via the Zoom chat pod at the conclusion of today's talk. The slides and video recording will be posted on our website, prevention.nih.gov/mindthegap, in approximately 2 weeks. Lastly, we would appreciate your feedback about today's webinar. Upon closing, you'll be asked to complete an evaluation. We would appreciate your feedback as it will help us improve this webinar series. At this time, I'd like to introduce Dr. David M. Murray, Associate Director for Prevention and Director of the Office of Disease Prevention.
Thank you, Dr. Moyer. Today's speaker is Dr. June Stevens. Dr. Stevens is an epidemiologist at the University of North Carolina at Chapel Hill, with over 25 years of experience as a principal investigator of NIH-funded coordinating centers for community-based multi-center trials. Currently, she is PI on the Research Coordinating Center for the Disparities Elimination through Coordinated Interventions to Prevent and Control Heart and Lung Disease Risk. This is called the DECIPHER study. That project includes 7 centers from around the country conducting implementation research aimed at reducing disparities in cardiovascular risk. Dr. Stevens has served as chair of the Department of Nutrition at the University of North Carolina and has chaired NIH workshops and working groups tasked with recommending clinical guidelines. She is a recipient of the Lifetime Achievement Award from the Obesity Society and the Centrum Research Award for Senior Investigators from the American Society for Nutrition. She also holds a distinguished professorship from the American Institute for Cancer Research. She has been an invited expert for the World Health Organization, the American Heart Association, the Centers for Disease Control and Prevention, and numerous NIH study sections. It's my very great pleasure to welcome Dr. June Stevens.
Well, thank you, David, for that very nice introduction, and welcome all of you viewers out there. I really appreciate your coming to listen to this talk, and I'm excited to share this with you. The ideas I'm going to talk to you about were published last December in the Journal of Implementation Science. And I'd like to now recognize my co-authors who are not with us here today. Sarah Mills, who's a behavioral scientist, Thomas Millett, who is a doctoral student currently completing his degree in implementation science, Bing-Chang Lin, a biostatistician, and Jennifer Lehman, an expert implementation scientist who taught me most of what I know about implementation science. So here's the outline of the talk today. I'm going to just cover some basics for those of you who are not familiar with implementation so that you have a little background to hold on to. Then I'm going to describe a brief literature search we did looking for type 2 hybrids with 2 RCTs. Then I get into the meat of the talk, showing you the diagrams that we have developed to make the DRCT design, and you'll see how we've broken down the components. I'll talk a little bit about how implementation strategies and interventions are interrelated, a few comments about power calculations, and then we'll have the take-home messages and closing thoughts. So the oft-quoted statistic is that it takes an average of 17 years for research evidence to reach clinical practice. And the idea behind implementation science is to reduce that 17-year time span. So we study implementation because there have been numerous developed health interventions that have been shown to be effective, but are not contributing to health because they are not being implemented. And we know that disparities in health are magnified by lack of implementation strategies that are effective in diverse populations. And therefore, we need this research to identify strategies for reaching diverse populations to increase uptake of interventions that will improve health. Now, Curran in 2020 published this very simple diagram to talk about what is implementation science. And he talks about the thing, and the thing is the evidence-based intervention. And then you want to get folks to do the thing by using implementation strategies. And you want to answer the question, did folks do the thing by measuring implementation outcomes? And then did the thing work by looking at the effectiveness outcomes? And usually, the implementation outcomes, this is the piece about did folks do the thing? You want to know things like, did the intended population participate, i.e. were they reached? Did the setting and the providers adopt the intervention? Did they implement the intervention with fidelity? And did they maintain the intervention over time? So that's the kinds of things you want to know with your implementation outcomes. The implementation strategies are how we achieve good implementation outcomes. And the strategies are used to enhance adoption, implementation, and sustainability. Now, in 2012, Jeffrey Curran coined the term hybrid effectiveness implementation as a hybrid design which takes a dual focus a priori in assessing clinical effectiveness and implementation. So there are three types of hybrid effectiveness studies. The first has a secondary focus on implementation and a primary focus on intervention. And the third type is the opposite, with the primary focus on implementation and the secondary focus on intervention. And then there is a type 2 that is focused dually on both implementation and intervention. And it's this type 2 that we're going to be talking about today. So a DRCT is a kind of type 2 hybrid design. In a DRCT, you, in the implementation strand, conduct a randomized trial to test the hypothesis that the active implementation strategy results in a more favorable implementation outcome compared to the control implementation strategies. And you also have an intervention strand in which you conduct a randomized trial, in which you have the hypothesis that the active intervention results in a more favorable health outcome compared to the control intervention. So that is a DRCT, a dual randomized control trial. Now, why would we do a type 2 hybrid instead of a type 1 or 3? Well, there's an efficiency in using one study sample to test both implementation and intervention. You may think previous research on the intervention has not been conducted in a pertinent population that you're interested in. Investigators may have concerns that adaptations of the intervention may have impacted its potency and want to retest it in its current form. And the investigators may think that previous research on the intervention is lacking or weak. And what is a DRCT? As I said, it is a kind of type 2 hybrid effectiveness study that uses 2 RCTs to test the effect of the implementation strategies on implementation outcomes and the impact of the intervention on health outcomes. These are usually multi-level studies in which the implementation strategies and outcomes are in providers, and the intervention and health outcomes are on participants. So why do a DRCT? Why use 2 RCTs rather than other types of study designs in your type 2? Well, it's because a well-executed randomized trial avoids bias due to the randomization and offers the strongest causal evidence with which to determine the truth of a hypothesis. You can find guidance on RCTs and on implementation studies from the Consort guidance and the STARI extension to consort. The STARI guidelines emphasize the importance of clearly identifying and differentiating implementation strategies and intervention programs. That may sound simple to you now, but it's really not a simple thing. It's something that investigators need to spend a lot of time thinking about to get clarity. So the STARI guidance suggests dual strands of exposures and outcomes, and the dual strands are the implementation and the intervention. So implementation strategies would be things such as those listed here, and interventions would be things such as those listed here. These would be the different types of exposures in the dual strands. Often the intervention is a named intervention that contains several components of intervention, such as those named here. Here's some examples of outcome. Implementation outcomes are things such as those listed here, whereas intervention outcomes are health-related in our type of research. They can be a health index such as BMI. They can be a health behavior such as smoking policy. They can be scores such as the Simple 7 or the Framingham. Those are the types of intervention outcomes. And again, these outcomes on the implementation are usually measured at the provider level, and the intervention outcomes are usually measured at the participant level. Not always. It doesn't have to be that dichotomy, but that's what you usually see. Okay, so that's my implementation basics. I want to move on now to a brief literature research that we did looking for type 2 hybrids with 2 RCTs. And this was conducted by Thomas Millett and Sarah Mills. So we searched for type 2 hybrid studies that used 2 RCTs that examine the impact of implementation strategies on implementation outcomes and examine the impact of the intervention on health outcomes using RCTs. We did a limited literature search. We did not look at the whole scope. We certainly could have missed things, but we were just trying to get a taste of how many studies there were out there and what methods they were using. So here I have listed the 4 journals that we used in our literature research. The search strategy was limited to the previous 6 years as well as to those specific journals. These are the search terms that we used. And you see here, we got 408 searching for type 2 hybrid studies, and the majority of those were from the Implementation Science Journal. We then looked to examine studies that examined both implementation and effectiveness, but did not limit the study design. That narrowed the field to 34. You can see again that implementation science had the most. So then we looked for type 2 hybrids that specifically used 2 randomized control trial designs. And to our surprise, we found 0. We did not expect that. We found 6 studies that came close. 3 looked at, 3 were about protocols for studies that, if they were enacted as the protocol said, would have been a DRCT, but we could not find any studies showing the outcomes of those protocols. A couple of studies reported only qualitative data, and the study by Garner is the one that came the closest, but there were design and analysis issues in that study that concerned us and didn't seem to fit. I'm now going to move on to our diagrams explaining the DRCT design. We were surprised that our literature review showed that there weren't any studies out there. And we began to think about, okay, how would we design such a study? And that quest took us down a long and winding road of thoughts and realizations. So get ready to concentrate as I share with you our process of designing a dual randomized control trial. So we start with our old friend, the basic randomized control trial design, which most, if not all of you, are already familiar with. So you have recruitment, baseline measurements, and randomization. In the simplest form, you have just two arms, an active and a control arm. You follow the individuals in those arms over time and measure outcomes, and it's the comparison of those outcomes that test your hypothesis. Now, this classic design isn't working for us here because we need to have two randomized control trials. So one way to do that is to just set two simple randomized trials side by side. And that would give you an implementation strand and an intervention strand, having these two trials. But this diagram misses the point that the setting is shared by the two studies. You may be studying different levels, but these steps here are shared between the two studies. So you can switch to a diagram that looks like this, where you can see that these steps are shared, and then you do a randomization into 4 arms. Here I've given you an example of what it might look like. You might have facilitation and coaching strategies in your active implementation arm and facilitation strategies alone in your control implementation arm. And then you would be measuring maybe adoption would be an example in your providers as your implementation strand. On your intervention strand, you might have the UNC Healthy Diet Program in your active arm and the Duke Rice diet in your control arm. These are both fictitious kinds of things that we are looking at here. Again, measuring adoption, but BMI in this case would be your primary outcome, and you would compare those. But there's still a problem here, and that is that I don't have the right arms, that there's supposed to be an implementation and an intervention in each arm, and I have 4 arms that separate the interventions and the implementations. So we can do this arm like this, where we have an implementation and an intervention in each of the 4 arms. But it was at this point that things really started to fall apart. And we began to realize that this approach was not helping us to focus on the critical hypotheses that we wanted to address. And it was not recognizing the links between specific implementation strategies designed to put on specific interventions. So we decided to start over. And we thought about, okay, what is it we really want to know? So as you know, we set out to use the randomized trial methodology to examine the effect of the implementation on implementation outcomes and the effect of the intervention on health outcomes. And with that as our mantra, we move forward. And we sort of did a decomposition of the pieces and thought about first the exposures. And here we're using Rothman's definition of exposures, potential causal factors that can be behaviors, treatments, traits, or exogenous factors, and can be naturally occurring or assigned. And in our case, they would be assigned. So our exposures that we're interested in are implementation strategies and intervention programs. And here we use S and P rather than using I and I for obvious reasons, and also because there's so much alliteration between implementation and intervention, it can be difficult to talk about the two. So we're going to talk about S for strategies and P for programs. Now, we're using this word program in a broad sense to indicate the 7 Ps that Brown has established are categories of intervention programs. So one type is a program, but we're using this word program to take in all of the 7 Ps. So these exposures of the implementation strategies and interventions programs have an active form and a control or comparison form. So you can see that the exposures of the strategies are active and control, indicated by a small letter A and C. And each study arm has 2 exposures. It has an S and a P pair. So for example, your active study arm would be S sub A, P sub A. That would be your arm. So I want to talk a bit about that arm because it's a very important arm. This is the package that you hypothesize will give more favorable results, and you want to eventually deliver, sustain, disseminate, and spread. So SAPA is the thing that you are most interested in, and you're hopeful that this is going to be a successful package. So we're putting our SAPA right in the center here. And then we're going to, here's our first few steps, and then we're going to devise an implementation strand and an intervention strand using our notation. So we start with the implementation strand. And what we choose as the control arm here is to use the same active intervention as is in the control arm, but use a control implementation strategy to compare to the active implementation strategy. This is the same type of comparison that people often use with a type 3 implementation effectiveness study. It holds the active intervention program constant and tests the implementation programs. And here you see you would measure the implementation outcomes as your primary outcome, and then compare those arms as your primary test of the implementation. So here's an example of this comparison. The active arm may be, the implementation strategy may be enhanced education and coaching to support community-based staff in the UNC diet program. And the control implementation strategy would just be routine education to support the staff. You see here that the intervention program is the same, the UNC diet in both arms. So you're using this strand just to test the implementation. Now, what about the intervention hypothesis? We know that SAPA is going to be our active arm that we're going to want to compare to, but what is the control arm going to be in the intervention strand? Well, we know we're going to have a control intervention, so we can, the notation would be PC. We want to compare to that. But what are we going to have as the implementation? This implementation exposure needs to address the control intervention program. And so we can't use PC because PC was used, SC, because SC was used to address the active program. Here you see SC is being used to address the active intervention program. Whereas in the control arm of the intervention, we want to address the control intervention arm. So I arbitrarily use this letter X to indicate that. And that is to show you and remind us all that SX is not exactly the same thing as SC, but it is the control exposure in the control arm of the test of the intervention. Now, I'm going to be talking more about SX in the future, but that is my introduction for SX. And what I want to show you here is another example. Here you see that the interventions are different, and therefore the implementations are different. This one is example is using the same one you saw earlier. It's the same arm, SAPA, and here we're using a different kind of implementation. And it is that implementation addresses barriers and promoters of the Duke diet program, because that's the intervention you're going to be given. So this is different from this. Okay, so here I'm showing you the whole diagram for the dual randomized control trial. Notice it has 3 arms. You could have more arms, but this design needs to have a minimum of 3 arms. The primary outcomes will be implementation outcomes in the implementation strand and intervention outcomes in the intervention strand, but usually you measure all outcomes in all three arms. Remember that there are different levels here. Usually the implementation is done at the provider level, and usually the intervention is done at the participant level. And I want you to note also that there's just one randomization. And usually the providers are randomized and the participants are nested within the providers, not doing a separate randomization. So that is the main analysis, the primary analyses. Now, most all investigators are going to do many pre-specified secondary analyses, but I want to talk about one particular secondary analysis that is very important, and that is the impact of the implementation on the health outcome. So in our notation, that would be the active arm versus the control implementation along with the active arm, but looking not at the implementation outcome, but at the health outcome. Because if you think about it, when you're doing this implementation research, in the end, you want the health outcome to be improved by doing so. It could be improved by having better reach. It could be improved by better fidelity, but ideally it would improve the health outcome also. So this is a very important analysis, but it is not a requirement of the DRCT design, but it's one that you'll probably want to do. So we've talked about this option here of the effect of the implementation on the health outcomes. And the point I want to make in this slide is you can do all three of these comparisons that we've talked about, the two needed for the DRCT and the one needed for testing the effect of the implementation on the health outcome in the design with the three arms that I showed you earlier. Okay, so I want to say a few words now about how implementation strategies are and interventions are interrelated. So the theoretical sequence of implementation study is to choose an evidence-based intervention first, then identify determinants. These are the barriers and promoters I'm talking about. Usually it's barriers to that intervention that you're focusing on. You create implementation strategies that address those barriers. You hypothesize implementation outcomes that you want to impact. And then you apply the implementation strategy, and after that, you apply the intervention. So I want to point out that although you choose the evidence-based intervention in the beginning of this timeline, you apply the intervention theoretically after you apply the implementation strategy. So that, operationally, it may not be exactly turning out like that, but theoretically, the intervention comes after the implementation. So why do we use here, I'm going to promise you I'd come back to this SX here rather than SA or SC. And that is because implementation strategies are tailored to the intervention. So if we look at the UNC diet program and we say it includes these things, this one-on-one delivery, sessions and phone calls, linkage to community care, and the Mediterranean diet. The PC program, that is the control intervention program, will be different. And perhaps as an example, it could have group delivery in specialized clinics instead of one-to-one, 8 in-person sessions, monitoring of carbohydrate intake, and a low carbohydrate diet. So the point being, implementation of the active intervention program versus the control intervention program is going to need to be different because the interventions are different. So the barriers to the UNC program might be things that I have listed here, whereas the barriers to the Duke program could be different things such as transportation, childcare, group dynamics, and the cost of low-carb foods. So the implementations will be different because the implementations address those barriers. So this is why you can't use the same control in the implementation strand and the intervention strand. One more thing I want to say about SC, that is the control exposure in the implementation strand. In a dual randomized control trial, this is where you see SC. And generally speaking, SC should not be an activity that is known will produce essentially no change in the primary implementation program. For example, an SA strategy to provide vouchers to a farmer's market to center staff and train those staff to distribute the vouchers to participants. Okay, that's an example active strategy. If the implementation outcome is % of center staff who distribute vouchers, for example. If FC does not include vouchers or training, then the % of the center staff who distribute vouchers will be essentially 0. You will know ahead of time that it is 0. And so often when the control implementation strategy is likely to produce a 0 change, and you know it will ahead of time just by common sense, it is often not a useful exposure to have. And it often abandons equipoise, which is a state of genuine uncertainty on the part of the scientific community regarding the comparative therapeutic merits of each arm in a trial that is key to ethical randomization of participants. So watch out for that. Okay, so why don't we just use a factorial design? So here you see a 2x2 factorial that you may be, most of you are probably familiar with this design. I most often see it in observational studies, but you can also see it in trials. An example here, let's say that the first letter is a video to discourage smoking. The second letter is the control is a video to that is neutral on smoking. Our second letter, the active arm, is a nicotine patch. The control arm, it's a placebo patch. And here in this 2x2, the primary purpose is to determine the main effects of each factor and interactions between factors. So I want to just do this comparison here. You see the arms in our notation that are in the factorial 4 groups, and the arms we have in the DRCT, testing control implementation against an active implementation and testing a control intervention against an active intervention. So here in this particular arm, the active implementation is paired with the control intervention. And this results in, for instance, preparing providers to administer an intervention that is different from the one you want them to administer. So it's this link between the implementation and the intervention that makes this sort of nonsensical. And similarly here, this SC has to make sense with the active intervention right here. And so if it makes sense with the active intervention, it probably won't make sense with the control intervention. So that's the reasons why the factorial really doesn't apply very well here. So it's not optimal because the focus is not on the active arm of the implementation and intervention, and that is the investigator. That is the arm the investigator has hypothesized to be best. The links between the implementation and the intervention can make some of the implementation and intervention pairs in a factorial not useful. And the implementation theoretically comes before the intervention, which sets up a potentially causal effect on outcomes. So another thought is that in a factorial, you have a minimum of 4 arms instead of 3, and that having fewer arms can be an advantage of the DRCT. You can add more arms, of course, but a 3-arm minimum. All right, so now I want to say just a few words about power calculations. So in a DRCT, you want to do 2 power calculations, one for your implementation outcomes and one for your intervention outcomes. Studies are often, but not always, group or cluster randomized in a DRCT, and the correlations within groups must be accommodated in the statistical analysis. And I must acknowledge that a group randomized trial often needs to be larger than a trial that randomizes individuals, so you need to be prepared for that. Do you need to control for multiple testing since you're doing two primary hypotheses in a DRCT? This is a question that my team is looking at right now, and we're planning on writing a paper on the subject. I'm not going to speak on that topic right now until we've gotten further with our paper, but it is something for you to look for. My advice to investigators is to make it a priority to involve a biostatistician in the construction and conduct of the power analysis, because this analysis is going to be complicated in this study. So we have made it to take-home messages and closing thoughts. So take-home messages. The DRCT is a kind of type 2 hybrid studies, not the only kind, but one kind of a type 2 hybrid study that uses two RCTs, one to examine effects of implementation strategies on implementation outcomes, and one to examine effects of intervention on health outcomes. A DRCT must have at least 3 arms, an active arm, a control arm for the implementation, and a control arm for the intervention. And each arm has an implementation and an intervention exposure. It's important to clearly define and distinguish implementation strategies and outcomes from intervention components and outcomes. And it's something that you should think about to consider other options for the control exposure in the control implementation arm if you have a strong certainty that it will result in no change in the implementation outcome. The implementation strategies must be appropriate to address the barriers and promoters of the intervention being used. Therefore, the implementation strategies and the intervention are linked. And you want to power the study for both the implementation and the intervention primary analyses. So those are my take-home messages. I have a few closing thoughts for you. For an implementation-focused study, why do a type 2 hybrid instead of a type 3, a type 1 or a type 3? I addressed this before, but I just wanted to repeat that there's an efficiency of using one study sample to test both implementation and interactions. And your previous research may not have been in your population, and you may be worried about that. There could be concerns that adaptations of the intervention have changed it so much that it could be different. So you want another test of its potency. And you may feel like, having looked at the literature, that the previous research was lacking or weak and feel like it needs to be repeated. So those are reasons for doing a type 2 hybrid study. Now, why do a DRCT? I will repeat that a well-executed randomized trial avoids bias and offers the strongest causal evidence for finding the truth of a hypothesis. And the strength comes from the randomization, which has the impact of controlling for both known and unknown sources of bias. But why not do a DRCT? When would you not want to do one? Well, I can tell you that they are expensive to do and complicated. Also, sufficient evidence of the effectiveness of the intervention may already be available, so you really may want to devote your resources to looking at the implementation and not restudying the intervention. Another reason not to do one is that the study procedures and handling of outcomes that maximizes your study goals in your study may result in compromise in the RCT methodology to such an extent that it introduces substantial bias and really doesn't hold the advantages of an RCT anymore. So probably is not a good choice for you. And last, the target sample may not find randomization and masking acceptable. So it just may not be a design that you can use. I've talked about guidances, and I want to encourage you to use Consort and STARI and other RCT guidances. And if your DRCT cannot be in compliance with RCT guidances, consider other study designs and or include a description of shortfalls in the publication of the work. So also, we know that currently DRCTs are not often found in the implementation literature. And our hope is that this work will encourage investigators to use the DRCT design to move forward research on public health practice. And with that, I have left lots of time for questions, and I welcome them.
Thank you very much, Dr. Stevens. And the questions have been pouring in since you began. We won't get through them all, but we can try to address as many as possible.
All right.
How do implementation studies differ from multi-level behavioral studies that measure process variables? Are the outcomes that you measure in an implementation study the same variables that would be measured as process variables in a multi-level behavioral study?
Yes, they are the same variables, and that is confusing. But when you do a behavioral study and you're measuring process variables, the measurements are the same type of measurements, but the emphasis on those measurements is very different. So for instance, in the DRCT, you're placing equal emphasis on the implementation outcomes as you are on the health outcome. So this results in a lot of changes in how you think about things. So with often process variables are considered less than secondary variables. They're not that they're not important, but they're less important to the investigator, and they may not be given the same kind of attention. You can think about it, particularly in the DRCT. I am suggesting that you do a power calculation to make sure you have enough power. You name a primary implementation outcome, which would have been a process variable, and you make sure that you have the design is clean and that you have enough power to test to do a test between an active and control implementation. That is the one big difference. The other thing is having a control implementation itself is not something that is normally done with process variables. Usually the process variables are concentrating only on the active arm and not measured in any type of control arm. And there's no control type of situation set up other than no control.
In the course of your presentation, you've talked about hybrid type 1s, hybrid type 2s, hybrid type 3s. I think Karan's original paper referred to these as designs, but you didn't use that term. You referred to these as studies. Is that based on Karan's follow-up paper from 2022? Or is there some other reason that you're not using the word design?
Yes, so Karan has decided that it would be better to use another word rather than design. So you have a study design, such as the DRCT, but the study is called the type 1 or type 2. And the design for the implementation may be different from the design for the intervention. You might do an RCT to test the intervention, but do an observational study to use an observational study design to do an examination of the implementation. So in order to avoid that kind of confusion, Karan has now suggested we use the word study rather than design.
All right. I think you've answered the question of why do a type 2 study? Why not just look at the impact of control versus active implementation on health outcomes? So we'll we'll skip by that one. You mentioned that implementation studies are often group randomized or cluster randomized. Why do you think that's the case?
I think it's the case because the kind of interventions that are being done and the implementation of those interventions, they need to have a broad reach. There's a lot of people they need to get to, and that's conducive to doing groups. Also, the provider setting is conducive to groups. So providers would take care of lots of different people. You want to train providers to deliver an intervention to not just one person, but lots of people. Often, again, because you need a wide group, that intervention is delivered to a group of individuals. And it's both a matter of increasing reach and also a matter of increasing the practicality of doing it. For instance, if you were doing an intervention in a school, you might want to put up signs in the school. You might want to change the whole PE program. To do it individually would be just not practical.
Thank you. In implementation studies, in my experience, investigators often make changes to the intervention or to the implementation strategies or things as the study is progressing. And that's in contrast to the more traditional classical RCT, where the entire plan is laid out in the protocol and you don't make changes without requesting permission to do so from the funding agency and usually a data safety and monitoring board. What's the best approach in implementation studies to avoid messing the design up by making these kinds of changes? Or is it a problem?
Yeah, it's a problem. I mean, it's an area of that's difficult. So I totally understand wanting to or needing to make changes as the study progresses, because you see that you see places where changes need to be made, where things can be improved, where things are not working, etc. There's a variety of different opinions that answering this question, but being a person who holds the rigor of randomized trials close to the heart, I have a tendency to be on that end of the spectrum myself, where I want to protect the rigor of the trial. Now, one of the things that I think you need to really think about as you are making plans to make changes in your studies are the generalizability of your study. So, this whole field of implementation science is based on wanting to get programs out, programs that work to improve health, out and being used in practice more often. So that statement itself means that you need a high level of generalizability. So where I kind of draw the fence around making changes is with that idea of generalizability. Are you doing something that can be exported in making the way you're making your changes, or is it going to be hopeless to export it because it requires a bunch of very high level study investigators making decisions about what changes should be made, which is never going to be available in the community settings where you're really hoping to see this implementation and intervention spread to. So that, I think, is sort of a guidepost that goes beyond the rigor of the RCT study for you to think about. So this whole line of thought makes me think a lot about an adaptive intervention design in which you plan for adaptations and how they're going to happen and who's going to be making them. And maybe you have some choices of adaptations that people in the field might choose from. So my idea would be to not to forbid making any changes, but to think ahead to make it possible for the settings that you want to export this package to do adaptations also. And so that is generally my answer to that question. Again, I think it's a controversial area. The other piece that I want to mention is if you are having to make, you feel you're making compromises in the RCT design, just be sure and list them in the in your discussion when you have your paper, and say, you know, we made this change in the middle of the study for these reasons. This may have caused bias. Just say that. And then I will feel like you have done your due diligence to the randomized control trial design.
Thank you. Challenging issue.
Yes.
One of our listeners notes that implementation outcomes are often measured at the cluster level, while intervention outcomes are often measured at the subject level or participant level. How does this DRCT handle that situation?
I think that part of handling it is usually the randomization is done at the cluster level. So you have one randomization done at the cluster level, and then the participants are at a different level are nested within the cluster level. So that helps with the design. Okay, that's the design piece that deals with the levels. Then there is the analysis issue. And here, I think, David, you are definitely the expert rather than I, but you need to be careful to control for correlation that may be occurring within your cluster, and account for that in your analysis, and also think about it in your power calculation so that you are sure you will actually have enough power to test your hypothesis.
Since the randomization is often at the cluster level, as you just said, and participants then are nested within those clusters, how can you be sure that the participants are comparable across the study arms?
Randomization. So that is the magic of randomization. You know, if you have enough units and you do a correct randomization, likely you will not have any problem. Now, that said, I think that doing a stratified randomization, if you have concerns about some of your clusters being very different from other clusters, where you stratified by this difference that you perceive may be in your clusters, and systematically spreading the clusters of different types into different groups, it also helps. People are using covariates in their final analysis if they have real concerns about some other variable impacting, perhaps biasing the outcome.
Would you accept a friendly amendment that constrained
Yeah,
randomization is another good approach,
Yes.
very similar to stratification?
Yes, absolutely.
Yeah. Do you have to in this DRCT? Do you have to power separately for the two outcomes? You've got an implementation outcome. You've got an effectiveness outcome. What if the sample size requirement is quite different for the two outcomes? Then what do you do?
Well, there you go. You know, so it could be quite different. And in an ideal world, you take the estimate that is the larger of the two, so that you have plenty of power for your health outcome and for your implementation outcome. Now, I will say it is helpful to us that the implementation outcome is often tested at the cluster level. So there are fewer units and possibly less power, but implementation variables generally are easier to impact than health outcomes. And so your health outcomes, you're at the participant level with lots of individuals, more units helping you there. And so it does sort of equalize it. But I think you could very well be in a situation where one outcome needed a lot fewer units than another outcome. And my advice would be to go with the larger estimate.
Do you have advice for our viewers today on how to do the power calculations? Are there software programs? Are there websites? Are there tools available?
Okay, David, I'm going to make you answer that question because that's not my area, and I think it is your area.
Well, I'm providing the questions that come from the audience. I do have my own thoughts about answers to some of them. There are plenty of resources out there for estimating power for this kind of design. The Research Methods Resources website that NIH supports is one such place where you can find tools to do that sort of thing. But there are many others. You'll find reference to lots of other tools at that website.
Yeah, thanks for the help.
So this is a tricky question. In the intervention strand that you described, there are two differences between the two arms. They differ in the intervention program. That makes sense, but they also differ in the implementation strategy because you've got SX for one and something different from the other. How do you know that the difference in the health outcome between the two arms is due to the intervention program and not due to the implementation difference?
You know, you really don't. And I think of the test of the intervention to be the test of the implemented intervention. And so you are really testing the implementation and the intervention. The other thing to remember is that an evidence-based intervention carries with it implementation strategies already. So when the evidence-based intervention was administered in another group, there were some implementation strategies that went with it. That comes with an evidence-based intervention. And then you or the investigator in their test of the implementations here are adding another type of implementation to that implementation already in the evidence-based intervention, if you choose to. Sometimes you don't add another implementation. For instance, you could be wanting to work in a setting where an intervention was already in place. So let's say that you were in a clinic and the clinic was using referrals to Weight Watchers to help people to lose weight. And you want to test instead using this wonderful UNC program that doesn't exist that I've been talking about today. In the control arm, there's already an intervention going on and there's already an implementation going on. So you don't need to add anything if you choose to use a usual care implementation and intervention. And then you would test those against the active implementation and intervention. So there's in the intervention strand, let me say. So there, in summary, you actually are testing the implementation and the intervention. I feel like when you're devising your control group for the implementation, it shouldn't be that different from what you would be doing if you were doing a behavioral study and measuring what we call implementation outcomes as process variables. The choices of the active intervention you want to test and the control for that intervention are very similar to what you would be doing in a behavioral intervention. So what do you think would be a good control group there? Would probably be a good control group in your test of the intervention in a DRCT. So you can kind of think about that intervention strand in the DRCT as if you were doing that same type of study. That's you have done perhaps, and I have done as a behavioral intervention that uses process variables.
Well, Dr. Stevens, we still have good attendance today and lots more questions, but we've run out of time. So I want to thank you for what I think was a lovely presentation and turn things back over to Dr. Moyer.
Thank you.
Thank you, Dr. Stevens and Dr. Murray. And thank you to everyone who participated in today's webinar. On the Mind the Gap website, prevention.nih.gov/mindthegap, you will find several resources for this talk, including the slides and a list of references. We will also be posting a recording of today's webinar on our website in a few weeks. Thank you and have a great rest of your day.